Welcome to BTEC Revision. In today's lesson, we're looking at temperature coefficient. By the end, we should be able to calculate the temperature coefficient of materials. How does temperature change the resistance of materials? Well, it's given by the temperature coefficient, which is a measure of how much a material's electrical resistance changes with a change in temperature. This is given by the equation change in resistance divided by initial resistance equals the temperature coefficient times the change in temperature, and the short form is given below. To work out the temperature coefficient unit, you'll have to rearrange this equation for alpha. So alpha will equal to change in resistance divided by R naught, and that would be divided by delta T. Now, looking at the units here, change in resistance is ohms. Resistance initial is also ohms, and change in temperature is measured in degrees Celsius or Kelvin. And we can see ohms cancel out, which gives us a unit of degrees Celsius to the power of -1. Here, delta R stands for the change in resistance, which is equal to the resistance final, take away the initial resistance. And on the right side, delta T stands for the change in temperature, which is temperature final, take away temperature initial. And we can write that as T naught, temperature initial. Now, plugging these values in, we get resistance final, take away resistance initial, divided by resistance initial equals alpha, bracket TF, take away T naught. And now we can simplify this. We have resistance final divided by resistance initial, take away R naught over R naught, which is 1. That's equal to the right side of the equation. And now we can move the 1 over to give us RF over R naught equals 1 plus alpha TF take away T naught. And then we can rearrange this equation for RF by multiplying both sides by R naught. Therefore, RF equals R naught square bracket 1 plus alpha curly bracket TF take away T naught close bracket and close square bracket. Now, let's look at an example. A resistor has a resistance of 120 ohms at 25 degrees Celsius. The resistance temperature coefficient for this material is 0.002 per degree Celsius. Calculate the resistance of the resistor at 40 degrees Celsius. You can start by writing down our equation delta R divided by R naught is equal to alpha delta temperature. Now, we can write down the values that we have. So a resistor has a resistance of 120. So that would be the initial resistance. And it's 120 ohms. The unit is correct, so we can leave that. And the starting temperature or initial temperature is 25 degrees Celsius. And then alpha is 0.002. And looking at the question, says calculate the resistance of the resistor at 40 degrees. So the final temperature is going to be 40 degrees Celsius, and therefore we'll have to calculate the final resistance. Now, looking back, we have worked out the equation for final resistance, and that is equal to RF is equal to R naught square bracket 1 plus alpha TF take away T naught close bracket close square bracket. Now we can plug in our values. R naught is equal to 120 close bracket 1 plus alpha, which is 0.002 bracket T final, which is 40, take away T initial, which is 25. And working this out gives us a value of 123.6 ohms. Now pause the video here and attempt this exam question. A copper wire has a resistivity of 1.68 times 10 to the power of minus 8 ohm meters. The wire has a length of 100 centimeters and a cross-sectional area of 1 micrometer squared. Calculate the resistance of the copper wire. To work out this resistance, we have to use our resistivity equation, which is R equals rho L over A, and rho is equal to 1.68 times 10 to the power of minus 8 times the length, which is 100 centimeters, and centi is times 10 to the power of minus 2, all over area, which is 1 micrometer squared. Micro is 10 to the power of minus 6. And plugging all these values in gives us a value of 0.0168, and the unit would be ohms. Now, part B is determine the percentage change in resistance when the temperature of the copper wire increases by 50 degrees Celsius, considering a temperature coefficient of resistivity for copper as 0.0039 per Kelvin. And we can work this out by looking at the right side of the equation, which is alpha delta T. And alpha, we know, is 0.0039. And then the change in temperature is times 50, because it says increases by 50 degrees Celsius. Now, something we can note here is when we're looking at the change in temperature, it doesn't matter if we put in degrees Celsius or Kelvin, because they would both give us the same change in value. And in this case, that would be 50. So working this out, 0.0039 times 50 gives us a value of 0.195, and that would be as a fraction. So to work out the percentage change, we would times this by 100%, which would give us 19.5%. And that's the end of the lesson. If you would like to boost your grades, visit us at btechrevision.com. See you next lesson.